Number 1. F of x is equals to logarithm base 5 of x plus 2. This is our table of values. And this is our graph. As you can see in our graph, the blue one represents our parent function. And the red one represents our logarithmic functions. So, our graph, we can describe that it is moving. So, we can conclude that the transformation of graph is a vertical translation, which means the graph of f of x is equals to logarithm base 5 of x plus 2 shifts the graph of f of x is equals to logarithm base 5 of x 2 units upward. And our vertical asymptote is x equals to 0. Our x-intercept, this is the process on how to get our x-intercept, so it is equivalent to -1. Our zeros is automatically equals to -1, and there is no y-intercept. Our domain is from 0 to positive infinity, and our range is -infinity to positive infinity. Number 2, f of x is equals to logarithm base 4 of the quantity x plus 3. This is our table of values, and this is our graph. As you can see in our graph, the blue one represents the parent functions, and the red one represent our logarithmic functions. So, our transformations of graph is a horizontal translation, which means the graph of f of x is equals to logarithm base 4 of the quantity x plus 3 shifts the graph of f of x is equals to logarithm base 4 of x 3 units to the left. And our vertical asymptote is x is equals to -3. And our x-intercept, this is the process on how to get x-intercept. Let's just equate y to 0. And as the result, it is equals to -2. And our zeros is equals to -2. Because as you can see in our table of values, 0 is equals to -2. And there is no y-intercept. Our domain is from -2 to positive infinity. And our range is -infinity to positive infinity.
Number 3, f of x equals negative logarithm base 5 of x. As you can see, this is our table of values and this is our graph. So the red one represents our logarithmic function, g of x equals negative logarithm base 5 of x, and the blue one represents our parent function, f of x equals logarithm base 5 of x. Comparing the two equations, we have the negative beside the logarithm. In that case, there is what we call reflection about the x-axis. So to describe the transformation of the graph of g of x equals negative logarithm base 5 of x reflects the graph of f of x equals logarithm base 5 of x about the x-axis. For our asymptotes, let us look at our table of values. At x is equals to 0, our logarithm approaches to positive infinity. Thus, it has a vertical asymptote which is at y-axis or x equals to 0. So our asymptotes is vertical asymptotes at y-axis or x equals to 0. Since we have the vertical asymptotes at y-axis, that means we don't have y-intercept. And we can see it pass through our x-axis which is at 1. Therefore, our x-intercept is x equals to 1 or 1 and 0. If there are x-intercept, there is always a 0. Let us look at our table of values. In our function g of x, we can see this 0 value. The corresponding of our y is 0 is at x which is equal to 1. That means our 0 is x equals to 1. Whatever value we have for our x-intercept is exactly the same with the value of our zeros. For our domain and range, since it will not pass through the negative values of our x, that means our domain is from the nearest value of 0 to positive infinity. Since our graph will move up and down, so the range would be -infinity to positive infinity. Number 4, f of x equals logarithm base 4 of -x. This is our table of values and this is our graph. In our graph, the red one represents our logarithmic function, g of x equals logarithm base 4 of -x. And the blue one represents our parent function, f of x equals logarithm base 4 of x. So comparing the two equations, we have the -x. In that case, there is what we call reflection about the y-axis. So to describe the transformation of the graph of g of x equals logarithm base 4 of -x reflects the graph of f of x equals logarithm base 4 of x about the y-axis. Asymptotes is vertical asymptotes at y-axis or x equals 0. So for our intercept, since it reflects about the y-axis, it flips at the other side, and therefore instead of +1, our x-intercept is x equals -1. So for our zeros, the same with x-intercept, x equals -1. For our domain, since it flipped, instead of positive domain values, the domain would be -infinity to nearest value of 0. And for our range, it will not change, -infinity to positive infinity. Number 5, f of x equals 3 logarithm base 5 of x. So this is our table of values, and this is our graph. So in our graph, the red represents the logarithmic function g of x equals 3 logarithm base 5 of x. So in the blue one represents our parent function, f of x equals logarithm base 5 of x. So to describe the transformation of our graph, the graph of g of x equals 3 logarithm base 5 of x stretches the graph of f of x equals logarithm base 5 of x. So for our asymptotes, it is vertical asymptotes at y-axis or x equals 0. And for our intercept, our x-intercept is x equals to 1 or 1 and 0, and we have no y-intercept. And for our zeros, the same with x-intercept, x equals 1. Our domain is the nearest value of 0 to positive infinity. And for our range, it will not change. It is -infinity to positive infinity.
Find the table of values first by substituting the x only since negative 3 is not a part of it to three numbers which are 1, 2, and 8, which is the base. In here, the logarithm base of 8 of 1 was equated to 0 because the x was 1. In here, in order to get 1/3, you need to use this formation a to the power of y of b. The exponential form of 8 is 2 to the power of 3, that's why we used it. So we'll use this formation, copy the 1, the y is 3 times logarithm base 2 of 2 since a and b is equivalent to 2. And it has the same value, that is why it was equated to 1. So 1/3 times 1 equals to 1/3. Next is this, since the value of base and the value of x is the same, it was equated to 1. These are the table of values. This is the g of x, and this is the parent function. The domain is 0 to positive infinity since it extended to 0 to positive infinity, and the range will always be negative infinity to positive infinity. Since this is a logarithm function, it doesn't have horizontal asymptote, but it has vertical asymptote, which can be seen in the y-axis for x equals 0. It has also x-intercept and 0, which can be seen very near to the number 0, and it does not. The graph g of x equals negative logarithm base of 8 of x minus 3 shifts the graph of f of x equals logarithm base of 8 of x 3 units downward and reflects about the x-axis. We will find first the table of values by equating negative x to three numbers including the base, which is 1, 2, and 3, the base. In finding the y, we will do substituting. In this part, any number from the base, as long as the x is 1, it will always equate to 0. In here, logarithm base 3 of 2 will equate to 0.6309 and divide by 7 to get the answer. As you can see here, the base and the x is the same value and it will always equate to 1, multiplied by 7 to get 7. As you can see, it has the same table of values. This is the g of x, and this is the parent function, or the f of x. The domain would be negative infinity to 0 since it extends from 0 to negative infinity. The range will always be negative infinity to positive infinity. Since this is a logarithmic function, it doesn't have horizontal asymptote but has vertical asymptote, which can be seen at the y-axis or x equals 0. Its x-intercept would be negative 1, and it doesn't have y-intercept. Since its x-intercept is negative 1, its 0 would also be negative 1. For the transformation, there is a vertical stretching, and the equation g of x equals 7 logarithm base 3 of negative x, and it reflects the graph f of x equals logarithm 3 of x about the y-axis. We will first evaluate the table of values by substituting x with three numbers which are 1, 2, and 8, which is the base. The logarithm was equated to 0 because the x is 1 despite what numbers in the base. Logarithm base of 8 of 2 is equated to 1 over 3 or 1/3. Negative 9 plus 1/3 is equals to negative 8.667. As you can see, the base and the x is the same value, that's why equated to 1, so negative 9 plus 1 equals to negative 8. These are the table values, and this is the parent function and the g of x. The domain will be 0 to positive infinity since it extends to 0 to positive infinity, and the range will always be negative infinity to positive infinity. Since this is a logarithmic function, it doesn't have horizontal asymptote but has vertical asymptote, which can be seen on the y-axis or x equals 0. It may not be seen here, but it has x-intercept and 0 since the graph will extend all the way through. Since the negative sign is not in the logarithm nor the x get real fraction, there is a vertical translation. The graph negative 9 plus logarithm base 8 of x shift the graph of f of x equals logarithm 8 of x 9 units downward.
Number 9, f of x equals to log base 2 of x plus 1. So we need to equate x plus 1 with 0, 1, and 2, which 2 is the base of our logarithmic function. To find its table of values, we can easily find the x value, which is x equals to 0 and x equals to 1. To find the y, all we need to do is substitute the values of x in our logarithmic function. So substitute 0, and we'll get the answer f of x equals to 0, and 0 will be our first value for y. To find the second value of y, all we need to do is substitute the value of x in our logarithmic function, and we'll also get the answer f of x equals to 1. So this will be the table of values for this function. To graph our table of values, I use GeoGebra.com as our graphing tool, and this will be the graph of our table of values with the blue line as its logarithmic function. It already have its vertical asymptote, which is x equals to negative 1, its zeros is x equals to 0, and its x-intercept and y-intercept is equals to 0, and its domain is negative 1 to positive infinity, and its range is negative infinity to positive infinity. To describe its transformation from the parent function to our logarithmic function, the transformation would be the graph of f of x is log base 2 of x plus 1, change the graph of f of x equals to log base 2 of x, 1 unit to the left. As we can see on the red dots, it moves once to the left. That is the transformation of our parent function to the logarithmic function. Number 10, f of x is equals to 9 log base 5 of x. So equate x with 0, 1, and 5, which is 5 is the base of our logarithmic function, and x equals to 0 is our vertical asymptote. To find the table of values, we already have the x, which is 1 and 5, and to find the y, all we need to do is substitute the value of x in our logarithmic function. So substitute 1. Always remember that the logarithm of 1 with any base is always equals to 0. So our answer of this one is 0, and 0 will be our first value for y. And substitute 5. And always remember that a logarithm with the same base and argument will always equals to 1, so that will become 1. And 9 times 1 is equals to 9, so the second value for y is 9. So to graph our table of values, I use again the GeoGebra.com to our graphing tool, and this will be the graph, which is vertical asymptote is x equals to 0, and 0 is x equals to 1, and its x-intercept is x is equals to 1, and no y-intercept for this function, and its domain is 0 to positive infinity, and its range is negative infinity to positive infinity. For the transformation of the parent function to our logarithmic function, the transformation would be the graph of f of x is equals to 9 log base of 5 of x, stretches the graph of f of x equals to log base 5 of x.